Hello and congratulations, you have reached the final lecture video for AMP2. I'm going to warn you, this video might be a little bit longer, it might be closer to 40 minutes or so, but this will be the final video. And so let's go ahead and jump into this. We are looking at the ovarian and uterine cycles for this video. And so that's going to be our focus, and then tie it up a little bit with some interesting tidbits at the very end. And so before we get started, just some terminology that may be helpful for you as you are going through. We've mentioned before that a lot of these processes occur and begin with puberty. And that term puberty is very broad. Puberty does not necessarily start at age 12 or 13. It actually starts as early as 6. And there's different stages of puberty. And there's mirroring stages, if you would, for male development as well, but what you're seeing here is more aligned to female development. And so what's varying here, the stages are the same. What's different here, of course, is the what's happening during these various stages. And so I've highlighted the key moments here. I'm going to just kind of caution you on understanding that there is no strict delineation as far as timelines. In other words, adrenarche, the first steps or stages, if you would, in puberty, usually happen somewhere between the ages of 6 and 8, and it can last up until 9, 10, 11, 12 years old. And so when I say there's no hard line of delineation, that's what I mean. Individuals are going to have different lengths of time that they are going to be in each of these stages of development. And so you can kind of see there that during adrenarche, first of all, note that term or that prefix, if you would, of, hold on one second, adrene. Right? So we're dealing with things of the adrenal gland, and this is where we see increasing levels of cortisol. So this is where metabolism is now going to start to increase, and we see the release of androgens, testosterone specifically, from the adrenal glands, and then that testosterone is converted into DHEA and DHEAS, dihydroepialdosterone sulfate. And for those that like me to spell things out, DHEAS, dihydroepi, aldosterone, phosphate. Now, fortunately, you're not going to have to spell that out for the exam. As long as you're familiar with DHEA and DHEAS, that is fine. These hormones are important in the development of DHEA and DHEAS, are critical for the development of secondary sex characteristics, including specific glands within the skin that begins to change the composition of sweat. So all of these things are kind of all going along during that adrenarche stage. Then you have thelarche, which is the onset of the development of breast tissue. Pubarchy is what we typically think of as being puberty. This is the development of pubic hair and axillary hair. And then menarche, which is the initiation of the menstrual processes, right? And so that first period generally happens in and around age 12, 13, 14, somewhere's in there. And so when we think of the processes that are involved here, and when we talk about things like puberty, understand that the entire process of puberty starts in and around age 6 or 7, and the onset of the menstrual aspect of puberty does not happen until about 6 to 7 years after the onset. Huge time span there. Stages of the menstrual cycle. I love it when I get an email. I don't get emails all day long. And when I start to record a video, I get an email. And you all can hear the ding for that email, for which I cannot edit out. Easily distracted. So, stages of the menstrual cycle. You have menstruation. So the physical act of menstruation actually starts all of this cycle. And that's kind of important to remember. Menstruation is not the end. Menstruation is the beginning. And that generally lasts for about a week, right? 5 to 7 days. These are all rough estimates. Nobody, I'm going to say this now, we're going to come back to this at the end. Nobody fits an ideal 28-day cycle. No one fits an ideal 28-day cycle. You might be 30 days, you might be 25 days, you might be 34 days, you might be 30. No one fits the ideal cycle. And so even though this is laid out as a 28-day cycle, you're not fitting that. You're not meeting that. No one is. And so don't get bogged down by this, right? Menstruation is the first part. It lasts sometimes 3 days, sometimes 7 or 8 days. Then we move into the follicular phase. And the follicular phase happens somewhere between day 6 and lasts up to right around day 14 or 15. And what's prominent about the follicular phase here is this is where follicular and oocyte development progresses. And so when we talk about meiosis 1 actually finally being finished, and we heading into meiosis 2 and arresting there at that stage of metaphase 2, at the completion of metaphase 2, that's happening during the follicular phase. And once we get the development and the maturation of the follicle and that oocyte, then we have ovulation, which is not really a phase, it's an event. Right? It's an event. It happens. It happens within the time span of this entire cycle. And so don't think of ovulation as a particular phase. It's an event that happens. And that can happen, that can go on anywhere is really between day 15 and 19 is what you would see. And then you've got the luteal phase, which we will talk more about, somewhere is right around day 20 up to about day 28. And this is where you've got that preparation of the uterine lining, right? You've ovulated, you may be pregnant, you may not. Remember, sex is not about reproduction primarily. It's about social bonding first. Reproduction is a beneficial byproduct of that. And so that uterus has to get itself ready, just in case. And after ovulation, it takes, again, about 4 to 5 days, 6 days for that ova to reach the uterus. So the uterus has some time to go ahead and be in preparation. And if there is no fertilization and there is no embryo, then you head back into the beginning of the cycle, which is menstruation. And so that's kind of the overall view of what we are looking at when we talk about the menstrual cycle. Now, this is where it gets a little interesting, right? Because there's regulatory processes. This doesn't just happen. Right? This isn't just a natural flow that just occurs on a whim. There's regulatory mechanisms that are in place. And for those of you that are visual and more cartoony in your approach to things, I figured this is a really good synopsis of what happens within this. And to me, this is a much more accurate representation than this. Because remember, no one is fitting this 28-day cycle. And so let's focus on what is happening, and let's de-emphasize necessarily those time frames that you see all too often associated with all of these cycles. And so I'm going to come in here. I'm actually going to change up, laser pointer time. Here we go. So let's think about what is happening here, right? Who are our key players? Well, we've got the pituitary gland right here, all right? And so this is our anterior pituitary gland. This is our posterior pituitary gland over here. Yay, very good. We have our ovaries that are over here, right? We have our oviducts that are right here. This is the uterus. And so what is the interplay between these two systems? Well, we refer to the interplay between the pituitary and the ovaries as being the hypothalamic pituitary ovarian axis, or the HPO axis. Remember, the pituitary gland is regulated by the hypothalamus, so we can't leave that out. Pituitary gland never acts on its own accord. But the pituitary gland, under the influence of the hypothalamus, does influence what's happening over here. And as influence is happening here, hormones are going to be released, as we will see, which is going to influence what is happening back over here. And so, what is this all about? Well, gonadotropin releasing hormone, GnRH, gonadotropin releasing hormone, is going to be released from the hypothalamus. And gonadotropin releasing hormone is going to cause the release of follicle stimulating hormone and luteinizing hormone from the anterior pituitary. And as we talked about in the last video, we know that luteinizing hormone is going to stimulate those thecal cells, and the follicle stimulating hormone is going to go ahead and coordinate the activities of those granulosa cells, which are there to support the oocyte in its development. And what ends up happening here is, because of the stimulation from luteinizing hormone and follicle stimulating hormone, what we end up seeing from the thecal cells and those granulosa cells is an increased production of estrogen. Right? It's an increased production of estrogen. And as estrogen levels begin to increase, what we end up seeing over here is a negative feedback on follicle stimulating hormone and luteinizing hormone. And so, but before this negative feedback happens, especially with luteinizing hormone, we actually see a positive feedback surge. And where we see that surge is with luteinizing hormone. And that luteinizing hormone increasing will increase the amount of estrogen, which increases the amount of luteinizing hormone, which increases the amount of estrogen. And what is happening here is, remember we said the follicle that can acquire the most follicle stimulating hormone is essentially going to be able to produce the most estrogen. And it's going to move through the stages of development of going from a primary oocyte to a secondary oocyte, or going from a primary follicle to a secondary follicle to that antral or tertiary follicle that is going to lead to the ovulation of the ova. And what eventually causes the ovulation? Estrogen is driving the maturation of the ova. Luteinizing hormone, which is intensified by estrogen release, luteinizing hormone is what is going to drive ovulation. Once that luteinizing hormone reaches a level, once estrogen reaches a particular level, that's when it becomes a negative feedback system. Estrogen is like, yeah, we're going to intensify this. We're going to surge luteinizing hormone. We're going to force it to pump out some more so we can drive ovulation. And then it's going to say, okay, back it back down. And it's going to become inhibitory, which is where we see that negative feedback kick in. And so ovulation happens. There's all that luteinizing hormone that is surging. Luteinizing or ovulation occurs. There's our little ova. Remember, the oviduct is not attached to the ovary. And so that ova needs to be drawn into the oviduct. And it's going to be in that oviduct for a good 4 to 6 days before it reaches the uterine lining. And we haven't talked about that. We're going to talk about this next. But after ovulation, and while the ova is traveling down that oviduct, the endometrial lining is thickening. That endometrial lining is thickening in preparation for the ova, just in case. Just in case. If it happens to be fertilized and we have ourselves an embryo traveling down here, it can implant. But the vast majority of ovulatory cycles do not lead in pregnancy. The overwhelming majority of them do not lead into pregnancy. All right? Think about how many times, if you are uterus bearing, if you got ovaries, think about how many times you have ovulated and how many of those ovulations have led to pregnancies. The vast majority of ovulatory cycles do not lead to a pregnancy. And so that's where, again, this is being sloughed off. And so let's look at this in a little bit more of a grown-up way. And so again, here is gonadotropin releasing hormone being released from the hypothalamus. Here's the anterior pituitary, right, ready to release its follicle stimulating hormone and its luteinizing hormone. Again, luteinizing hormone is focused on those thecal cells. Follicle stimulating hormone is focusing on the granulosal cells, driving the development of that primary oocyte into becoming a secondary oocyte so that it is ready for ovulation. Right? And again, estrogen that is now being released from those granulosal cells drives the luteinizing hormone to drive its concentrations up. That's what we call the LH surge, or the luteinizing hormone surge, which leads to ovulation. Right? And then remember I said that the uterine lining has to take some time to get ready? Well, this corpus luteum is what is left over of the follicle after ovulation has happened. And what will happen here is the corpus luteum secretes progesterone, estrogen, and inhibin. And all three of these, inhibin works more on the cervix, but the estrogen and the progesterone, really, the star here is progesterone. Progesterone is what drives uterine preparation. And if after about 6-7 days there is no implantation, this corpus luteum disintegrates and becomes what we call a corpus albicans. And the corpus albicans is essentially scar tissue. It's connective tissue. Remember, we talked about that scar tissue builds up. Collagen rushes in and takes over that corpus luteum. And that's what scar tissue is, right? It's collagen. And no more progesterone, no more inhibin, no more estrogens. And so what happens is that stratum functionalis gets sloughed off. Again, these are things that we have talked about already. And this is what we ended the previous video on, was looking at this development of the primary follicle, right, or that process of going from a primary follicle to a secondary follicle that will eventually, this is the secondary here, that will eventually start forming this antrum, this space of nutrients and fluid, right, that fills it. And by the way, the formation of the antrum is why we call this a antral follicle very often. This is that tertiary follicle. And that tertiary follicle reaches a point of ovulation, and that's what we refer to as a Graafian follicle, right, with its very well-defined granulosal cells, its very well-defined thecal cells. You have something that's called a zona pellucida. If you look over here, okay, that zona pellucida is kind of that gray area that is surrounding the ova. Okay, you can see it here as well. You can see it here as well. You can see it there as well. That zona pellucida stays with the oocyte even after ovulation. And in fact, it's the zona pellucida that will create a barrier that the sperm has to get through in order to actually get to the ova. And there is a surge of calcium that is then released. There's a surge of calcium that is then released that will inhibit any other sperm from entering in once that sperm breaks through that zona pellucida. And so this is just another look at this. You've got this slide for this. I'm not going to spend much time on this, but this is a histological view of what you're seeing here. And so back to our comics here. Here we've got FSH. Remember, that's acting directly on those thecals or on those granulosal cells. That's driving follicular development. And by follicular development in here, we're talking about moving from a primary oocyte into a secondary oocyte that's happening in here, right? We're going from a primordial follicle. This is your primordial. The This is your primary follicle. This is your secondary follicle. And this is your tertiary follicle or antral follicle. And then the follicle that undergoes the ovulation, because of that surge in luteinizing hormone, this would be your Graafian follicle. And then what happens to that follicle afterwards, again, this is all part of that luteal phase, right? We're getting down here's the uterine lining, we're getting that uterine lining all nice and thick and ready for a potential embryo that's coming in. And so this here would be your corpus luteum, and then this here would be your corpus albicans. And then menses would happen, or menstruation would happen. And you can see what happens here. We're going to look at this a little bit more as far as what hormones are influencing this. But you see starting the thickening of that lining. And then that lining gets even thicker with all that blood supply that's coming in. And then menses happens, and it thins back out again. And then it goes through that cycle once again. And so you can kind of see where the uterine cycle overlaps with the ovarian cycle. So let's take a look at this. And you've got this diagram. This diagram is probably the best thing that you can look at and have. And so please pay attention to this. That figure right here, this bad boy right here, summarizes really everything that you need to know as far as the hormones that are involved in driving the ovarian cycle. So this is your pituitary hormones, up here luteinizing and follicle stimulating. These are your follicular hormones, estrogens and progesterone. This is your ovarian cycle, and this is your uterine cycle. That is down here. And so everything is laid out for you. But this really is a story of layers. This is a deep, rich, complicated, intriguing, fascinating story that has these 4 layers, right? You've got your pituitary hormones, you've got follicular development, and by the way, if we think about this from the standpoint of connection, all right, and I'm going to color code this for you. I encourage you to kind of do the same thing. So under uterine development, the menstrual and the proliferative phase, menstrual being the shedding of the stratum functionalis, the proliferative phase, which we haven't talked about yet, being the starting the building back up of the stratum functionalis. Both of these equate to the follicular phase in the ovary. So the menstrual and the proliferative phase is happening concurrently as the follicular phase is happening. And that makes sense because hormones that are being impacted and released here are influencing what is happening down here. And then, gotta change pen color. I haven't used green much. The secretory phase that you see here goes along with the luteal phase. And that secretory phase, as you can see down here, this is where the stratum functionalis gets all of that engorging of the blood. Here's your spiral arteries that are in here. They branch off. They start delivering all of that blood. Nutrients, oxygen, ATP, glucose, all of that going into this area. That is matching the luteal phase, which up here is characterized by the presence of the corpus albicans, or the corpus luteum, that's driving all of that progesterone and estrogen that's driving this. And so remember, ovulation is not a true phase. It's an event. Right? It's an event. Okay? And so kind of keep that in mind. Right? The follicular development and uterine development do definitely overlap. And then you've got these characters, if you would, the pituitary hormones and the ovarian hormones. Think of follicular development and uterine development being the setting, and your characters being your pituitary hormones and your ovarian hormones, because that is where they are acting. Right? That is where they are acting. And so what do we see here? What do we see here? Well, let's look at this. Remember, we have 20 to 30. Here's your all of your primary oocytes are all down here. These are all your primary oocytes, all down here. All right? 20 to 30 of them begin to enter into that secondary oocyte stage. They begin to release estrogen, and that estrogen is due to, come up here, the beginning releasing of luteinizing hormone. And that estrogen, and then you also have some follicle stimulating hormone here, although those levels are starting to decrease. The reason why you see a decrease, it starts out high and it decreases down here, is because you have fewer and fewer of these secondary follicles. Remember, they go through atresia. Those that cannot absorb follicle stimulating hormone undergo atresia. And so the levels of that follicle stimulating hormone starts to reduce to allow the dominant follicle to absorb all of that follicle stimulating hormone to drive primary and secondary oocyte development. The estrogen that's being produced is driving luteinizing hormone surging. Look down here. Here's your estrogens down here. Look at that increase. That comes in here. It corresponds with that surge in luteinizing hormone. And that is what triggers ovulation. If you look right here, this is ovulation. That line between the blue and the green, this is where ovulation happens. This is where ovulation happens. Estrogen levels surge, causes a surge in luteinizing hormone. This is that negative feedback that starts to happen. Estrogen levels start to drop. Look what happens to follicle stimulating hormone and luteinizing hormone. They begin to drop as well. And as these levels drop, ovulation is done, and we move from the follicular phase into the luteal phase. And this is where you've got the corpus luteum. And this is where now the corpus luteum, remember I said, drives progesterone levels. This is where you start to see that massive spike in progesterone. You start to see a little bit of a spike in the estrogen. And it's the progesterone, primarily the progesterone, that is driving the secretory phase, or the phase in which the stratum functionalis is getting all that blood supply, all that nutrients, all of that gorging of the blood in preparation for implantation. And when that doesn't happen, progesterone and estrogen levels fall because the corpus luteum becomes the corpus albicans here. And that's what drives those levels down. And as soon as you lose progesterone and estrogen, then you enter into the menstrual phase, which you can see happening over here and finishing up over here. That complete sloughing off of the stratum functionalis that is going there. And so this diagram explains that beautifully. By the way, I will just kind of add in here that It is during the menstrual phase, right here, that stratum functionalis, typically what is experienced is somewhere between 33 mils and 270 mils of blood loss. And it's generally during that blood loss where we have, it's why individuals are most prone to being anemic, because you've lost a certain amount of blood. It depends on how heavy that menstrual flow is. Right? It just depends. And a lot of that is dependent upon how high the progesterone and estrogen levels get. What was their concentration levels to drive development of that secretory phase? And so there's going to be some additional slides that I have included for you in the PowerPoint that kind of breaks this down a little bit more for you. But this is the big overarching picture that I need you to try to relate, correlate, and understand. These here, I gave you these images broken down. So again, these two images are on one. These two images are on a separate one as well. All right. And so you've got all of those diagrams that are there, a little bit easier for you to see. Right? I do want to remind you, to be reminded of that we talk about this as a linear process, but that recruitment of 20 to 30 follicles that go into this process happens in waves. So at any point in time, the ovary actually has 2 to 3 overlapping waves of follicles that are going through this process. So one wave happens, and then 2, 3, 4 days later, a second wave will start to be initiated. And then about a week after that, sometimes a third wave will be initiated. So you've got 3 sets of 20 to 30 follicles that are undergoing this process. So that way you have the ability to do ovulation roughly every month to month and a half, 2 months. You've got this curling that's going on, or recruitment that's going on, to prepare that next Graafian follicle for ovulation. And so when you really think about this, right, this is not a 28-day cycle. This is not a 28-day cycle by any stretch of the imagination. Really what you've got going on here is what's 28 days is, what is 28 days is the primary oocyte going to a secondary oocyte, ovulation happening, and then that luteal phase happening. That's what's 28 days. But understand, this has happened way before, right? This is actually a 290-day process. Now, if you, here's the irony of life, right? If you divide 290 divided by 30 days, you get 9 months. It takes 9 months to get to this ovulation and then sloughing off, or this luteal phase that's building up the uterine lining, and then the menstruation to happen. It takes 9 months. Pregnancy is 9 months. After that, here's the thing. These 290 days are not consistent. These 290 days are including what is happening between weeks 18 and 20, if you would, during fetal development, and the initial development of those primary oocytes and primordial follicles. This is including what is happening in the cultivation of those 20 to 30 follicles as they start moving from primary to secondary oocytes, or as they start moving from the primary follicle to the secondary follicle to the tertiary or antral follicle and reaching that Graafian follicle. This is all inclusive of everything. And so I think that's really important to remember, that 28 days is really far-fetched when we look at this. This here is just, again, just kind of breaking down that follicular phase and the luteal phase and what is happening. Remember, dead smack in the middle. Let me change my color here. Dead smack in the middle here is, it's probably the worst color I could have chosen, ovulation. Right? Dead smack in the middle there is ovulation. Interesting point that I do want to make up is that only about 10 to 15% of individuals have that 28-day cycle. So when I say that females really don't have this, you're dealing with such a small percent of the population that may fall perfectly on that 28-day cycle or 29-day cycle that is there. It really is not common. When you've got 90%, when you've got 85 to 90% of the population that does not fit what we consider to be normal, it's not normal. Let that sink in. When you've got 85 to 90% of our population that does not fit what we are told is the normal, what you're told is the normal is not the normal. The 85 to 90% is the norm. Right? And so let that kind of just be a guiding force for you in thinking about this. And hold on one second. So this is just a cute little animation that kind of illustrates everything that we've been talking about. And so let me play it for you. You can play this as well. So you see the sperm coming up. You've got follicular and ovarian development that's happening over here. And there goes ovulation. Here comes the sperm. This is that zona pellucida. That is right there. Has to get through that zona pellucida. And it does. Wave of calcium is going to be released. It's going to stop all other sperm. And fertilization is going to happen now. Fertilization happens. Our little embryo is going to start going through that process, dividing. 8 stage. We're going to go into the morula stage right there. This is the embryonic pole, and it's going to join in. This is that stratum functionalis, and you've got implantation that has happened. Right? And so that is what we are talking about. Fertilization does not equal pregnancy. You are not pregnant at fertilization. You are pregnant once implantation happens. And I think that's the tricky thing, because we've got clinical pregnancy. Clinical pregnancy, when they determine your date of pregnancy, they pick the day after the last day of your last cycle. So, yeah, your clinical pregnancy dates is the last day the day after the last day of your last cycle. Societally, according to society, you're pregnant as soon as fertilization happens. 60% of fertilizations, 60% of fertilizations never implant. Only about 40% of fertilizations actually reach to the stage of implantation. And therefore, it can be considered, that is when pregnancy starts. And so implantation equals pregnancy. Fertilization does not equal pregnancy. Just a couple, I want to just give you a couple tidbits here. Back in the 40s, 1945, is when work around defining the statistically average male and female happened. And these individuals, the statistically average male and statistically average female is what we refer to as norma and Norman, right? Or the normal female, the normal male. This is where we get all of those dimensions of what the chest should be and the waist should be and the hips should be and what we consider to be the ideal man. There's some challenges with this, right? And so they used World War I soldiers to define statistically average males and females. Studies of the old American stock so they looked back into history and took what they considered to be the ideal individuals. College women and men, mainly college men, because women still were not heavily present within colleges back in the 40s. Sampling of the World's Fair and Chicago attendees. Insurance records. And a sampling of about 15,000 women by the Bureau of Home Economics. And by the way, the Bureau of Home Economics set the standards for women clothing sizes. Now, think about this. Who were most of the World War I soldiers? They were white males. Who went to college in the 1940s? Primarily white males and white females. Who went to the World's Fair? Who could afford to go to the World's Fair in Chicago in the 1940s, 1939, 7, right around there? White middle-class individuals. Who could afford insurance? White middle-class individuals. And who do you think was reading and subscribing to the Bureau of Home Economics? White middle-class women. And so statistically average males and females were actually based on white middle-class males and females. Anybody see any problems with this? Anybody? By the way, this represents the person that closest identified to the statistically average female. The statistically average male and female doesn't exist. We always are trying to live up to an idea that doesn't exist. Doesn't exist. Norma and Norman are not real people. What they did was, same thing with ovarian cycles. They took all of this data and they took an average that fell in the middle. You're not going to represent the population when you do that. And normal, back in the 30s and 40s, meant average, but only for desirable populations. And so what did they do? And notice the data that was collected. It excluded people of color. It excluded queer individuals. It excluded individuals with disabilities. It excluded multiracial and multi-ethnic individuals. And it was this idea to promote what was correct or good. And if you did not fit the normal, nose, hip, eyes, hair color, texture, size, build, all of these things, then you must be abnormal. Something pathologically must be wrong with you. You must be unfit. Our idea still in 2024, when this video is recorded, we still use this idea of norm and normal. What is normal? What is the average person? That average person is a fallacy, not representative of the entire population. And the reason for that is because this research was a offshoot of eugenics. Eugenics started in the United States. Eugenics started in the United States. Hitler stole the idea of eugenics from us here in America. Let that kind of sink in a little bit as well. The last couple of things I want to touch on here, and I apologize, I said this would be a longer video. We have a lot of assumptions about sex hormones, right? Estrogen, as soon as I say estrogen, you all are probably thinking female. As soon as I say testosterone, you're probably thinking male, right? We now know, you better after listening to these lecture videos, that males produce estrogen and testosterone. Females produce estrogen and testosterone. And sperm production is predicated on estrogen levels. The ovary produces testosterone. Our brain development is dependent upon estrogen. And so these assumptions around sex hormones are just not accurate. And so this is testosterone, right? For those that are not biochemists, right? This or organic chemists, I guess, even in that sense. This is testosterone, and this is you now know this is your larynx, right? And this is the prominence of the larynx that is right there. What is typically referred to as the Adam's apple. And what will happen is all individuals have that laryngeal prominence. Every person has a laryngeal prominence, which means every person has an Adam's apple. The difference is there is enlargement variation based off of exposure to testosterone. Testosterone, higher levels of testosterone during fetal development and again during puberty will increase the size of that laryngeal prominence. Higher concentrations of testosterone leads to larger, more well-defined laryngeal prominences. But all individuals have laryngeal prominences. And of course, that is right there where the vocal folds are, the vocal cords. And so the larger the prominence, it actually causes deeper voices within males very often. And the last thing I will leave you for on this very last video of AMP2 is assumptions around sexual dimorphism. We always hear that female hips are wider than male hips, right? And very often in textbooks, lab books, pictures, you see this difference. This here would be a female pelvis. This here would be the male pelvis. Well, this is actually representing what we refer to as the ultra male and the ultra female, the ideal, quote unquote, the norm. When we actually look at population studies and when we actually measure male and female pelvises, this is more so what we see. The size difference is much closer to one another. It's harder to distinguish a male pelvis and a female pelvis for the vast majority of the population. And in fact, some male pelvises actually are wider, and some female pelvises are actually more narrow. And so this falsehood that there is sexual dimorphism within the pelvis is just not accurate of the overall population. It's the outliers. Again, it goes back to what is normal. These are those statistical outliers that we've accepted as being the norm when they're not. The norm is much more homogeneity in the size and shape of the pelvis. This is representing that 10% that also would have, let's say, a 28-day cycle. Right? You can't define normalcy off of 10% of a population fitting the ideal or the norm that was defined off of false premises. 85, 90, 70, 60% of the population defines the norm. And this is what we see within even hip structure. And so with that, I hope that you have a much broader understanding of gonadal anatomy and reproductive physiology and biology. It's not a binary case. There's so much diversity within this. And we try to control that narrative with this false assumption of binariness that I hope you now see or at least are open to understanding that there is a lot more variation out there than what society tries, some segments of society try to report on and push and make people think and or feel. And with that, I am not going to say my normal on this since this is the last video. Instead, class dismissed.